Hello, and welcome to today's webinar, How and Why You Should Form a Materials Informatics Strategy. My name is Rachel Darasek. I'm the Vice President of Marketing and Product Strategy at Lux, and I'll be your host for today. Our presenter is Xiao Zhang, an analyst on Lux's materials team. Xiao, tell us a little bit about yourself.
Okay, that sounds good. Thank you, Rachel. It's a pleasure, to talk about materials informatics, which is a very interesting technology. We see lots of momentum. So my background is chemistry and materials. I have been at Lux for almost 2 years, covering the materials design and manufacturing coverage area, including some of the technologies like materials informatics, 3D printing, and generative design technologies. It's a pleasure to talk today.
Thank you, Xiao. I know those are some of the hottest areas at Lux during the time you've been with us. So before we get into your presentation, I wanted to quickly pause and introduce Lux to everyone who's joining us today. Our members have a singular focus, and that is to drive growth through tech innovation for their organizations. Now, when we talk with our clients and think about driving growth, it really boils down to two key use cases. The first is to build a commercial business case to decide to start doing something new, something inherently different within your organization. The second is to chart the course once you've decided what it is that you want to do. At Lux, we help our members with both types of decisions. We partner with innovation executives at global Fortune 500 companies in industries such as materials, energy, agri-food, health, and digital, to help them make the right decisions about which technologies to prioritize, who to work with, developers, partners, acquisitions, etc., and when is the right time to act. Our analysts, 73% of whom have advanced degrees in science and engineering, just like Xiao, will always provide their honest, informed opinion. Their opinions and insights are based mostly on primary research. They have daily conversations and interviews within our ecosystem of clients, industry associations, government and academic institutions, startups, and more. And their insights are further enhanced by our advanced analytics capabilities, such as data science and machine learning. So with that, let's turn our attention back to Xiao, who's going to give us his Lux take on opportunities in materials informatics and really demonstrate the type of insight that Lux provides to our members on a daily basis. At the end of the webinar, we will take a few questions. So if you'd like to submit a question, please use the Q&A box on your screen, and you can enter a question at any time. Xiao, over to you.
Thanks, Rachel. So it's always a pleasure, like I said before, to talk about materials informatics. It's definitely a technology Lux has been tracking since the past few years. We have seen definitely the progress of this technology and the business strategy becoming more matured. That's why we think now is the time for you to think about how you should form your materials informatics strategy. So I want to start my talk by talking about Thomas Edison, which is a hero of mine. So Edison is the greatest inventor of all times, and this is a picture of him holding a light bulb, which he also invented. What you may also know is that in order to identify the best material for the light bulb filament, which is tungsten, Edison tried over 3,000 materials. That's lots of materials. It's very time consuming and it's very costly. But Edison did the best of he could. There was no computer, no digital technologies to help him. So now the question is, with the modern age digital tools, can he do a better job faster? And also we know that tungsten is the best material of the 3,000 materials he tried. Is it really the best material? Can there be a better material, right? So with that, I want to talk about another hero of mine, Tony Stark from Iron Man. So this is a screenshot where you see Tony used digital technologies to first discover a new element called vibranium. Then he actually used vibranium-based energy materials to build the energy source for his suit. And according to the movie, he did so in a few days. So why am I showing you those two heroes of mine? Because you can argue that the holy grail of materials innovation is to move us from the Edison stage to the Tony Stark stage. Obviously, we're still far away from Stark, but we have just passed Edison. I'd like to argue that materials informatics, it's an emerging technology that has the promise to help us achieve so. So now let's talk about today's agenda. First, I want to talk about why you need to form a materials informatics strategy. And then I want to talk about some strategies that we have seen. Specifically, there are 3 strategies we have seen. I want to go through each of those strategies with you and talk about which one of the 3 we think it's the most data efficient strategy. And then last, I want to talk about how do you execute that strategy. So let's go back a little bit to ground zero. So what is the problem that the materials space is facing? It's timing. It takes a long time. In fact, it takes about 10 to 20 years to develop a new material. That is very slow. And like I said before, materials informatics, it's an emerging technology that can help you accelerate that dramatically. So now let me define what is materials informatics, and then I will talk about some of the key benefits to give you a better understanding of this technology and its promise. So on the surface level, materials informatics uses artificial intelligence technologies to accelerate chemical and materials development. There are definitely many benefits. Some of them include the following. So first, you can think of using materials informatics to accelerate materials and chemical research product development timelines. In other words, it can help you to increase your R&D efficiency for chemical and materials companies. Second, you can think of using materials informatics to extract additional value from your data, both experimental data and computational data. Last, but certainly not least, you can use materials informatics to optimize your design of experiments more efficiently so that each experiment, each data point really counts. And here, you're on the right, you're seeing a figure. This is a typical materials informatics project where you use AI tools to help you to do high throughput screening of, to find the material with the right electrical resistivity, which is one example. So at this point, I defined the problem, right? Materials development, it's very slow, and I introduced materials informatics and its benefits. Now I want to talk about, some of the efforts that the governments are trying to put together. In short, governments around the world have definitely seen, the promise of materials informatics. They have seen the problem that materials development, it's very slow. There's initiatives being taken. For example, President Obama launched the Materials Genome Initiative, MGI, 8 years ago to leverage materials informatics for the US. So the goal here is to accelerate the materials development process by a factor of 2. And also US is not the only country, right? So the slide has some other example initiatives from other parts of the world. You see the MGI there, and also China, Japan, and Europe. There's different types of initiatives being built. So the underlying message here is that governments around the world definitely have seen the promise, the problem, and also the promise of materials informatics, what it can offer, and they have already taken some actions to build collaborations, to build software infrastructures and databases. So that's the background there. Okay, so I defined materials informatics. One of the questions that I often get asked is, how does materials informatics fit into the existing materials design paradigm? So let's talk about that here. You start with experiments. That's the Edison approach. You do experiments physically. It's very accurate, but it's also very slow. Then there came computer. Now you can think of doing modeling and simulation. So that is to say, now you can do experiments virtually on a computer with physics and theories, right? It's much faster, and it's definitely complementary with experiments. But of course, the trade-off is the computing power consumption. We are basically at this stage for the past 2 decades. Now, recently, with the development of AI tools, and also computing power getting cheaper, we're entering the third paradigm where we have materials informatics come in. So materials informatics is complementary with this existing two components. Think of using materials informatics to analyze the data you generate from experiments and from modeling and simulation, then to provide the feedback on insights to guide better experiments and better modeling and simulation. So I did talk about the importance of data when I'm introducing this paradigm. Yes, data is very important. It definitely sits at the center of this paradigm, and it's the field for materials informatics, and it's the field for this new paradigm to progress. But I don't want to just talk about data's importance, because on the flip side, data also brings some significant challenges. Just to name a few, there's definitely this data quantity challenge. We just never have enough materials data, and it's very expensive to acquire additional data, computationally and also experimentally. And also, when you're dealing with the data, there's this issue of data formats. You don't have the same format, and also there's structured and unstructured data, which makes your job even more difficult to do so. Just because of these data challenges, and also on the other side, materials informatics is really a promising technology. We do think corporate players need to think about how to form a effective materials informatics strategy to correctly access their data to fully realize the benefits for their companies. In other words, you need to form a materials informatics strategy now. Okay, hopefully at this point I have convinced you that there is a need to form a materials informatics strategy now. Now let's talk about how do you form one. This is a map of known materials informatics partnerships. The different colors indicating different types of organization. From this map, we can see 3 different strategies, and I'm going to work you through one by one, and also provide some analysis there. So let's talk about the first one. I'm highlighting this node here, Citrine Informatics. It's a startup company. So the first strategy is to work with a startup company, right? So working with a startup company is definitely the quickest approach for any company to just get started with materials informatics. But to do so, you're going to have to share your data with the startup. So if data security is your top priority, it's your concern, you should think further before doing any actions. There is a case study here where BASF is working with Citrine Informatics to develop new catalysts using Citrine's AI platform. So in this case, BASF shares data with Citrine, and Citrine uses that data and apply that data to its platform called Citrination to do high throughput screening for potential catalyst candidates. According to BASF, this partnership, this collaboration has been accelerating the development process for BASF. Okay, second strategy, I want to highlight these companies here from this map. So these companies are claiming they have started their own internal materials informatics initiative. So by doing so, they are completely eliminating the data security concern because they don't have to share data with other companies. But on the other side, starting an initial initiative, first you have to think about finding the right talent, which is actually in this case very difficult because I don't think I know any universities or institutions that offer a PhD program, for example, for materials informatics. Finding the right talent can be really challenging. And also, even if you have the talent, either by hiring or training, which will take some time, you are going to have to think about how to organize your data internally to build your own materials informatics data platform, which can take a long time as well. So both of these can potentially require lots of upfront investment. So here is a slide showing you some details about these companies that I highlighted on the last slide. As you can see, different types of materials are being explored. There's rubber materials, which is polymer, and also there's metal. And in terms of different applications, we see Toyota is doing materials for energy applications. And more interestingly, you see Mitsubishi Chemical is actually building a center to use their data to do materials informatics. So as you can see from this slide, and also through my conversations, I often find that there are lots of Japanese companies that are actually very active in this space. So I really want to highlight that Japan, in fact, it's very active in this space. So the last strategy I want to talk about is definitely the most interesting and radical strategy. That is to form a consortium with your peers. So a consortium here means a group of organizations, oftentimes led by a trusted company or a government agency. And then there's member companies joining, and these members oftentimes have data they have to share, and then they identify a problem of mutual interest based on a pre-competitive agreement, and then they share data from for that problem. And there's often technology providers to solve that problem using materials informatics. So obviously, this is a good data strategy because you can combine the resources of data from your peers, but potentially the resulting IP can be a concern. Who will own the IP? So here I want to highlight the work that was done by NIMS, which stands for the National Institute for Materials Science. NIMS, it's a Japanese government agency. It formed a consortium with 4 Japanese companies 2 years ago to build a platform together called the Materials Open Platform, MOPE. So MOPE promotes innovation in the chemical and materials industry using materials informatics. And to get started, these 4 companies, with the support of NIMS, are collecting polymer data together. As you can see, they're collecting some basic polymer data, polymer structure data, and also physical property data. So I talked about the 3 strategies. Now let's compare them together. So like I said before, if you just want to get started with materials informatics, working with a startup is definitely the quickest, but also it brings significant data security concerns. On the other side, if you want to eliminate that concern completely, you can think of starting an internal materials informatics unit. But again, so because of the data-centric nature of materials informatics and it's highly technical, you may be looking at a very large amount of upfront investment. That's why to balance, the 2 issues that matter the most, that's data and investment, we do think that the consortium model is the best way of leveraging materials informatics. And this is the most data efficient way of doing so. Okay, so now we talked about the 3 strategies that we have seen and provide analysis and comparisons to show you that we think the consortium model is the most data efficient way of realizing your materials informatics strategy. Now let's talk about how to execute one. So first of all, I like to say that each consortium is different, and there's no universal protocol, but there's some elements that are really in common you have to think about. So first, I think government support is very important because such a consortium, involves you have to share your data. It's definitely built on trust, and having a third-party government entity to lead and organize this consortium, it's very important. And also, you have to define the scope and the type of data you can share, and you have to do so very, very carefully, right? So that's why pre-competitive agreements are really needed. You have to define which problem, what type of data, how much data from which company you can share. So a pre-competitive agreement, it's very important as well. And lastly, but certainly not least, probably the most important factor here is the IP strategy. So we're going to have some resulting IPs out of this consortium. So the question is, who will own the IP, right? A correct IP, effective IP strategy is very important in the sense that you must think of, give some IP privileges to the consortium members, but you can only do so for a given amount of time to facilitate further innovation. So these are the three elements that we think are important. But in essence, a successful consortium, involves multiple stakeholders. To help them work effectively together. We need to make sure each of their incentive is well aligned. In fact, to a higher level, not only we think the consortium model is the most data efficient way to form a materials informatics strategy, we also think that the consortium model is an evolution to the chemical and the materials industry and potentially beyond. So consider a scenario where we have several mid-sized chemical and materials companies that each of those companies doesn't really have the resource to compete with the leader in the space. But these companies do have data synergies with each other. Think of these companies form a consortium to now they do have a chance to compete with the leader. So what will be the result? Potentially, we're going to see some competitive landscape reset. Now maybe they will be the new leader. And also, I've talked about the example where the consortium is formed by peer companies. It doesn't have to be. Think about some cross-value chain collaborations. Think about a chemical company forming a consortium with a chemical user company. There's definitely that data synergy from upstream and downstream of the value chain. And it may be easier to do so because these type of companies, they're not competitors. And when this is happening, we're going to see some business model change because now the boundaries between different parts of the value chain will become more blurred, and we're going to see business model change, and potentially we can think of not only including the chemical materials companies and chemical materials user companies, but also maybe some software companies, some startup companies, as well as the government groups. We're going to see lots of change in terms of the business model, but I do believe this will be the changes for the better. And with that, I'd like to stop here and take questions. Thank you very much.
Thank you, Zhao. That was great. I'm still blown away by that number at the beginning that talks about something taking 20 years to develop. It's unbelievable. For those folks on the phone with us today, just a reminder to type any questions into the Q&A box on your screen. I see lots of questions coming in, so Zhao, let's get right to the first one. It looks like the consortium idea is a pretty hot topic. So let's look at this question. The question says, can you be more specific about how to form a consortium, how to handle IP issues, data sharing, etc.?
Yeah, thanks, Rachel. That's a very interesting question. So there's no simple answer for that, but I do think there's a few elements we have to consider. So first of all, like I said before, I do think it's better to have a neutral party, maybe like a government agency, to run the consortium. It definitely ensures trust. And also some other critical components of the consortium will include first, technology providers. These can be startup companies, let's say national labs or universities that have the technical capability to analyze data using materials informatics. And also the other component, the obvious one, it's the member companies. These are the chemical companies, materials companies, or maybe automotive, aerospace. If they have the issue to solve and they do have the data they can provide through a pre-competitive agreement. And besides those components, you also need to think more creative about forming a project, a committee, maybe to prioritize which projects, which data you want to share, which project you want to carry on first. And you can think of select the committee members from those components like technology providers and the member companies and the government agency that is running the consortium. So these are, I think, are very important issues. And also there's a question you asked, it's about data sharing. I think it's important to get started with your legacy data. These are the data that people normally don't find of any additional value. These are the data you think of, or you're not using them in the short term, right? So because of materials informatics capability to unearth additional value from this legacy data, starting with legacy data to share, it's a very good start. So I think the last point, Richard, you asked, it's also about how do you handle the IP. So we do want to file patents, and I do think the member companies that provide the data should own the IP, the patents. But at the same time, we do want to give some incentives to the technology providers, let's say national labs and universities, the chance to publish their work on academic journals, but maybe you should let them do so after a embargo period, 6 months or a year or so. That's very typical. So hopefully that answered the question.
Yes, thank you. Win-win-win. Some things you said about data sharing resonate with what I've heard a lot of your colleagues on the research team talk about how much data is collected and wasted and how expensive it is to store. So I would think if you could extract some value out of stored data that you haven't done anything with in a long time, it would be a great thing to do. Let's get to the next question. So the next question is also about consortium. You talked about the NIMS consortium. Are there any other consortia you're familiar with?
Yeah, so there's quite a few consortia, actually not in the materials space. In the pharmaceutical space, there's quite a few consortia, but just for the materials space, I do know a couple. So first, there is a consortium organized by IBM. So IBM organized the consortium with 12 projects, including materials informatics, and they have a name of that project called Accelerated Materials Discovery, and there's another 11 projects as well. So the name of the consortium is called the Research Frontiers Institute, and the idea here is to use IBM's computing power, AI expertise, and some of the data. They do have data as well to work on problems of great importance. And besides that one, there's also another consortium on a smaller scale. It's organized by the American Society for Metals, ASM. ASM organized this consortium with 3 universities as technology providers and also a few companies. So they're following the model that I just described before. There's committee, and there's technology providers and data companies that providing data. So these are the ones that I know. And also I want to talk about a recent conference, LUX actually co-organized with NIST, which stands for National Institute for Standards and Technology. NIST is the major participant of the MGI I talked about during my webinar. So we see the need to talk about and think about how to form a materials informatics strategy. In fact, so that's why we had a conference in Chicago 2 months ago to talk about how do you form your own materials informatics strategy. And in that conference, we brought in relevant stakeholders from government, also from academia groups, and some of the corporate players and startups. I thought that was a very good point to mention as well.
Yes, it sounded like that conference at Northwestern with NIST went really, really well.
Yeah.
There was a lot of value there. So let's take one more question. I think we're going to run out of time pretty quickly here. The last question here is, how do you check or evaluate that using materials informatics is an efficient way to do R&D compared to without using materials informatics? Seems like a pretty good question to be asked by a scientist.
Yeah, exactly. So that's a question that I can talk for like an hour, but looks like we're running out of time.
We only have a few minutes.
Yeah, so many ways to check that, right? So in a short term, so I talked about legacy data before. So these are the data that you normally just toss out or save somewhere you never use. But think about, what if materials informatics can show some value out of this data, doing data mining immediately? So that's actually a very quick way of seeing materials informatics value immediately, right? So here I want to talk about a conversation we had with a leader in the space. So last month we had our LUX Executive Summit, and part of that presentation section, we invited the CTO of Cabot Corporation, Patricia Harbert, on stage, and somebody was asking the same question to her actually about how do you check materials informatics really being valuable, and she actually gave an example of using materials informatics to discover new lithium-ion based material that without that technology, she said they would have never thought about that solution. So I thought that's a very good case in point as well. So yeah, that's pretty much, given the time, I think these are the two aspects I can talk about.
Thank you, Wenzhao. That was a nice wrap up in just the last few minutes we have here. And thank you again for this really great presentation, all your insightful thoughts and comments, and especially answers to the questions. Unfortunately, we weren't able to get to all of the questions that came in. So if you submitted a question that we didn't have time to answer, we will follow up with you directly. And if you'd still like to submit a question, you can email us at questions@luxresearchinc.com. And of course, if you found today's presentation inspiring or interesting or insightful, tell your friends, tell your colleagues. You can follow Lux Research on LinkedIn, Twitter, YouTube, or check out our blog for ongoing informations and insights about materials informatics and a host of other topics. And you can always contact us directly to learn more about how we can help you drive growth through tech innovation for your organization. Thank you for joining us.